So if we don't have rolling updates, when we want to create a new resource, like for instance, let's say I just have one pod, and I do a kubectl edit on that pod to change the image. Actually, I don't even know if I can do that. But if I could, it would end up just like killing that pod, creating a new pod. So what I want to do is do that in a more controlled way, and I need a construct on top of that, and that's the whole point of deployments. A little note is that if you look at Kubernetes documentations and older tutorials, you will see stuff about replication controllers, replica sets, deployments, etc. Replication controllers are the old way of doing things. And I will see if I have a few minutes at the end to explain the key difference. But the short version is that now you should use deployments. Deployments are going to create replica sets, but generally you won't create replica sets directly yourself. You will manipulate deployments, and then when you update a deployment to say I want this image or I want to change this parameter, the deployment is going to have multiple replica sets corresponding to new and old versions, and it's going to do communicating vases. You know, it's going to shrink one of the replica sets and increase the size of the other to do a progressive rollout of the new version. Okay, so when you do a rolling update, you have two parameters that are important: max unavailable and max surge. Max unavailable means how many pods do I want to take offline during the update. So for instance, if I have 10 pods and I put max unavailable equals 1, it means it's going to shut down a pod, put the new version, and then when it's up, it's going to shut down another, etc., etc. I have another parameter, max surge, which indicates how many extra pods do I want to create during the deployment. So for instance, I could say max unavailable 0 and max surge equal 1. And in that case, I would keep my 10 pods, but now I would start by creating a new one. And when it's up, then I would remove the old one, etc., etc. If you put max unavailable equals 0 and max surge equals 0, you're stuck. You can't do anything because you can't start anything, you can't stop anything, so your deployment will never go anywhere. If you want to be like super fast, you can set max unavailable equal like 100 and max surge equal 100, which means YOLO. And now when you try to roll out, it's going to stop everything and start everything, and then there is no point in having a deployment, so I don't recommend it. You can set those numbers in absolute values, like X pods, but you can also indicate a percentage, like 10% or 50% or whatever. And then there are a few like pseudo math formulas to kind of repeating in a different way what I just explained. One of the really interesting things with those rolling updates is that you have a big undo button. If something goes wrong, you can push the undo button, and it means like let's say this is the old replica set and this is new, so you're kind of you start like that and you're like creating new stuff and destroying new stuff, and at some point you're like, oh crap, we just shipped a critical bug in production. So you hit the undo button and both replica sets are going to go back to the original state. Let's see that in action soon. Yeah, first I wanted to mention that rolling updates are available on deployments, daemon sets, and also another resource type, stateful sets, which is when you want to run databases and other stateful services in Kube. Yes?
So from there, Kubernetes knows that the new version works well.
How does Kube know that the new version works well? So Docker has the ability to specify health checks, and then those health checks can bubble up to Kube. So you can define, like, you can give Kube ways to assess the health of your pods. So two options: either you don't do that, and then Kube is just like, okay, we started the pod and it's running, so hopefully everything is fine. Or you can define your health check, And in that case, Cube will use that to know if the pod is really up and running. So that's great, because if you have an app that takes 20 seconds to start and whatever, you can have that health check, and then Cube will bring up the new app, patiently bring up the new pod, wait until the health check is clear, and then it will go to the next one, etc., etc.
Okay, so it can even like curl something a bit.
Yeah, absolutely. You can, for instance, if you can also, if you want to be a little bit fancy, if you say, okay, I know that during the first minute or something like that, the app will serve requests, the pod, will serve requests, but it will be slow because it's still loading stuff, etc. If you want, you can do a custom health check that would be like a curl with a timeout or something like that, and the health check will be okay only once the thing can respond in less than 200 milliseconds or whatever.
Can this health check restart my application into runtime if I think that something goes wrong?
Can the health check automatically restart the app? It can. So it gets a little bit tricky here, because you can have multiple different behaviors depending on what you want to do. Sometimes the general idea when you work with microservices is that your health check should be something that tells you if this microservice, in that case, if that pod is working, and it should not rely on anything else. And this can be super complicated, because let's say you're testing like a web front end, and that web front end connects to a database. You need to make sure that when you check the health, it should say okay, even if the database is down, because you don't want to page the people maintaining the web stack if the problem is with the database. And at first, when we say that in abstract concepts like that, it's like, yeah, of course, that sounds like a good idea. But when it's time to put that in our microservices, that can get really tricky, because, okay, so I need to test the user microservice, but when the user backend is not available, how can I confirm if it's working or not?
It's good only for backends.
Yeah. Okay, so we are going to roll out new versions of the code. So I'm going to edit the worker code, and I'm going to change a line of code in there. So I'm going to orchestration/stacks, and I edit Docker coins /worker/worker.py, and then we can see that here we have a sleep command as well, and I'm going to increase that sleep command to 1 second, and then I exit and save, and now I have to rebuild and repush and everything. But first I have to set a tag, so I'm going to do export tag equal v0.2. Do I have my registry variable set here? No. So kubectl get service registry. Okay, it's on port 3800. So export registry equal localhost port 30800. And now I do docker compose -f dockercoins.yaml build. So I'm going to build the new version of my app, and thanks to the caching mechanism in Docker, that was super fast. Then I'm going to push the new version to the registry, and thanks to the caching mechanism in Docker, that's going to be super fast as well. And now I'm going to update the definition. So I'm going to get back here, and kubectl set image for deployment worker, and I put worker equal localhost colon 30800 colon v0.2. So I want to explain a little bit what is this kind of weird command that just appeared, like kubectl set. Kubectl set is a kind of clever wrapper to change spec in various object types. So in that case, this is exactly the same thing as doing kubectl edit deployment worker, and then we go into the spec and there is image and we change the image that we use and we save and we exit. This is just a different way to do that. /rng like this, yeah. So here I say I want to update the image in deployment worker, and you might wonder, why do I have worker equal blah blah blah? Why don't I just have like -- image or something like that? It's because remember, we are updating a pod specification. A pod can have multiple containers. So when I do that, I say that I want to update the image for that container in the pod. There is that container name is worker in that pod. And when I do that, stuff happens here. So you can see that's the deployment. And what I would like to show is like kubectl. Well, that's already done. That was too fast. But I should maybe at some point find an example with a bigger image or whatever, so we can have more time to see what's going on. But that thing just happened. The thing where we add more pods in a replica set and we drain the other replica set until we're done.
Did you now replace the works by RNG? Was that a mistake?
That's a good point. Yeah, I just replaced the worker by RNG, so I think if I look at the I'm too excellent. That's absolutely not what we wanted to do, so I'm going to fix that right away, like this.
Doesn't look like you fixed.
RNG
RNG already broken.
Okay,
worker.
Yeah, I broke worker, so now I'm fixing worker. Yeah, and it's coming back. Yeah, I'm glad you noticed this because I think it was like.
Did you say that could have been undone just with an undo?
Yeah, I could have done kubectl rollout undo on deployment worker, and I'm going to show that just after as well because I'm going I'm going to do a deliberate mistake now. I'm going to say, oh, I want to update the worker to tag v0.3, which, by the way, doesn't exist. So I do kubectl set image deployment worker. I put tag 0.3. So now I have like container creating, and obviously I have error image pull. So now I have the time to show what the numbers here are for. This is like my target number. I want to scale to 10. And this is the number that corresponds to the surge. So it's like how many pods are out there for that deployment. This is how many pods are healthy. So 9, because by default I have a max unavailable of 1 and max surge of 1. So it means I'm updating 2 pods at a time, kind of. So that means, yep, I'm trying to update 2 pods now, but it's stuck. And if I do kubectl rollout status deployment worker, it's telling me waiting for rollout to finish. 2 out of 10 new replicas have been updated. That's when I'm going to use the undo. So kubectl rollout undo deployment worker. And the rollout was pretty quick. And I don't think this is really visible in the web UI anyway, because it's just a little bit lower, a little bit higher. But we only had 90% of the worker capacity for a moment. Okay. If we want, we can change these rollout parameters. Like, for instance, here I want to go back to v0.1, but I don't want to terminate any container. I want to start the new containers first, and then once they're up, shut down the old containers. So in other words, I want max unavailable 0 and max surge, let's say 3. So I could do a kubectl edit deployment worker, But I wanted to show you yet another way to edit resources. And we can do that with a YAML diff. So I don't know if this is super readable from where you are, but this is a partial spec. And I say the spec for the deployment is that the template for the pods has the following spec, and then I can apply that with kubectl patch. And so if I do that, I have to set the registry. Okay, so poof, this has completed. So I can do export registry equal localhost 30800. Yep, and then I'm going to copy paste that thing. And so it's going to update 3 workers at a time. If I might have screwed up something, maybe. Get pod status, image pull back off. Yeah, maybe what did I do here?
We never defined the tag version 0.1.
That's a good point. Yeah, I did not define 0.1, so that's where it's stuck.
So you need to use latest.
Whoa. kubectl rollout status deployment worker. And now it's updating them 3 at a time.